Okay, let's find the solution to this system of three equations and three variables. The sequence of how we do this is going to be different depending on which variable we choose to eliminate. I'm going to choose to eliminate x because I can easily see how I can make something times 2 is pretty easy to give me 4. And I can multiply this x by 2 to get this 2 as well. So let me go ahead and number my equations here just like we did in the video. So this is equation 1, equation 2, and equation 3. I'm going to go ahead and pair up equation 1 and 2. And to do that, I know I'm going to have to multiply equation 1 by negative 2. So I'm just going to write that out in front. And then I'm just going to keep equation 2 as is. And then all of that, when I actually multiply by negative 2, for equation 1, I will get negative 4x plus 2y minus 2z equals negative 20. And then for the equation 2, it's just going to remain the same. And then since I have a negative 4x and a positive 4x, I'm going to go ahead and add those together. And I'll give 0x, but I'll have 4y minus 5z equals negative 10. I'm going to go ahead and call that equation 4. Actually, I'm going to use red on that just so it all looks the same here. That's equation 4. And now I'm going to do the same thing and eliminate x again, but this time I'm going to use equation 1 and equation 3. And I know that in order to have the same coefficient with opposite signs in front of x in equation 3, I'm going to have to multiply by negative 2 there again. So the top equation just stays 2x minus y plus z equals 10. And the bottom equation is going to be I'm just going to write it out as it is right now and then go ahead and do the multiplication. So when I do that, I get equation 1 stays 2x minus y plus z equals 10. And equation 2 becomes negative 2x plus 6y minus 4z equals negative 16. And then once again, since the x's have the same coefficient but opposite signs, I'm going to add these equations together. So I'll have 5y minus 3z equals negative 6. So we'll call that equation 5. And now with equation 4 and equation 5, I have the same two variables. So let's look at those two equations sort of at the same time here. So I've got 4y minus 5z equals negative 10, and I have 5y minus 3z equals negative 6. So I've got to get the same coefficient in front of one of my variables. You can choose to either eliminate the y's or eliminate the z's. It doesn't really matter here. I'm going to go ahead and multiply that top equation by 5 and the bottom equation by negative 4. And that's going to give me 20 and negative 20 as my coefficients for y. So if I rewrite that, equation 4 and equation 5, I'm going to have 20y minus 25z equals negative 50. And then negative 20y plus 12z equals 24. And once again, since I have the same coefficient with different signs in front of one of my variables, I'm going to add these equations together. So that's going to give me negative 13z equals negative 26, which will give me z equals 2. And then I can just continue to substitute backwards. So let's go ahead and, let's substitute z equals 2 into equation 5. So I'll have 5y minus 3 times 2 equals negative 6. So that's 5y minus 6 equals negative 6. 5y equals 0, and that gives me y equals 0. And then I'll back substitute one more time. Let's go ahead and substitute both z equals 2 and y equals 0 into one of our original equations. I'm going to choose equation 3. All right, so I'll have x minus 3 times y, which we know is 0, plus 2 times z, which we know is 2, and that's equal to 8. So I've got x minus 0 plus 4 equals 8, and we get x equals 4. So my solution to this entire system, I write as an ordered triple in this form, x, y, z, in alphabetical order, and that solution then is going to be 4, 0, 2.